In this video, we will learn to solve linear inequalities with one variable. Solving a linear inequality is similar to solving a linear equation. The main difference is that the solution to an inequality is a set of numbers rather than a single number, and all of the numbers in the set satisfy the conditions in the statement. The statement x is less than or equal to 9 means the solution set is 9 or any number less than 9. Compare the number lines below. In the first number line, the parenthesis tells us that the boundary 9 is not part of the solution. This number line is represented by the inequality x is less than 9. In the second, the bracket tells us that 9 is part of the solution set. So this number line is represented by the inequality x is less than or equal to 9. Example, solve the equation 4x plus 6 equals 2x minus 2, and the inequality 4x plus 6 is greater than 2x minus 2. We do these the same way. We solve it exactly the same way. We just keep the symbols the same. So when we have this 4x plus 6 equals 2x minus 2, we subtract a 6, we subtract a 6 from both sides, and we subtract a 2x from both sides. And we wind up with 2x equals negative 8. Divide both sides by 2, x is negative 4. Only difference over here is that here x is greater than negative 4 instead. And we can write the solution set of the inequality in set builder notation, the set of x such that x is greater than negative 4, or in interval notation, the interval from negative 4 to positive infinity, or as a number line, starting with a parenthesis at negative 4 and going up. Another example, solve the equation 3x plus 5 equals 7x plus 13, and the inequality 3x plus 5 is less than 7x plus 13. So here we have Here we subtract 3x and 13 from both sides of the equation. We wind up with negative 8 equals 4x. Divide both sides by 4 and get negative 2 as x. Here, however, this is a little different because we wind up with negative 2 is less than x. And while that's fine to write, it's not usually the way we write it. We usually write x first. So negative 2 is less than x means the same thing as x is greater than x, the same thing as x is greater than negative 2. This illustrates an important difference between equations and inequalities. In an equation, we can freely interchange sides. Negative 2 equals x is the same as x equals negative 2. But we can't do the same thing in an inequality. Negative 2 is less than x is not the same, is not equivalent to x is less than negative 2. Those are different. Negative 2 is less than x is equivalent, that's what those three lines together mean, to x is greater than negative 2. So if we change the signs, we have to change the direction or the sense of the inequality symbol. I'm going to use that term sense throughout this section. Sorry, the pages are sticking together. There we go. Interchanging the sides of an inequality. When the sides of an inequality are interchanged, the sense of the inequality is reversed. So if A is less than B, then B is greater than A. If A is less than or equal to B, then B is greater than or equal to A. Likewise, if A is greater than B, then B is less than A. If A is greater than or equal to B, then B is less than or equal to A. Multiplying or dividing an inequality by a negative number. If both sides of an inequality are multiplied or divided by a negative number, the sense of the inequality is reversed. If A is less than B, then negative A is greater than negative B. If A is greater than B, then negative A is less than negative B. So we've multiplied this inequality by -1, and we have to reverse the sense. We have to reverse the direction of the inequality symbol. If A is less than or equal to B, then negative A is greater than or equal to negative B. If A is greater than or equal to B, then negative A is less than or equal to negative B. To solve linear inequalities, first, we follow the same sequence of steps that we normally use to solve a similar linear equation. The sense of the inequality remains the same unless A, the sides of the inequality are interchanged, or B, the steps used in solving the inequality require that the entire inequality be multiplied or divided by a negative number. Finally, if either A or B occurs, we reverse the sense of the inequality. So here we go. Let's solve this inequality. 4x minus 2 is less than or equal to 3 times 25 minus x. So the first thing we're going to do is distribute, and we only have to do that on the right. So we multiply that 3 through 25 minus x and get 25 minus 3x. So then we'll add 3x plus 2 to both sides and get 7x is less than or equal to 77. Divide both sides by 7. X is less than or equal to 11. We don't have to change the sense because at no point do we multiply anything or divide anything by a negative number, and we don't interchange the sides at all. We can write this in our set builder notation form as an interval or as a number line. Solve the inequality 2x minus 3 times x plus 2 equals 5x minus, and I forgot the parentheses here, x minus 5. So again, the first thing we do is we distribute. So this negative 3 times x plus 2 becomes negative 3x minus 6. This negative x minus 5 becomes negative x plus 5. We combine like terms on each side. We get negative x plus minus 6 is greater than 4x plus 5. And I add 6 and subtract 5 from both sides. So that gives me negative 11 is greater than 5x. And then we're going to interchange the sides because we want that x on the left. So that's 5x is less than negative 11. Divide both sides by 5. X is less than negative 11 fifths. And of course, we have other ways we can write that. Finally, we've got an application example. An electrically controlled thermostat is set so the heating unit automatically comes on and continues to run when the temperature is equal to or below 72 degrees Fahrenheit. They're wasting a lot of electricity and a lot of money. At what Celsius temperature to the nearest hundredth of a degree Celsius will the heating unit come on? We use the formula. Degrees Fahrenheit are equal to 9/5 times degrees Celsius plus 32. We know the degrees Fahrenheit are 72. So 9/5 the degrees Celsius plus 32 is less than or equal to 72. We subtract 32 from both sides to give us 9/5 times degrees Celsius is less than or equal to 40. And then we multiply both sides by 5/9, the inverse of 9/5. And that's going to give us that the degrees Celsius are 200 over 9, or 22.22 degrees Celsius.